while learning PyTest. Hi everyone and welcome to the complete 1-hour PyTest course. Here you will learn everything you need in order to become a software test engineer with PyTest. If you want to check out the complete 9-hour PyTest course, please check in the description. Hello everyone, I thought it might be quite useful for you because jumping into the actual coding, for you first to learn in what types of testing PyTest is actually used. Well, I would have to tell you that PyTest is used in all types of testing known in the software development industry. It is used for testing, integration testing, end-to-end testing of the full system and of the subsystem components that are creating the whole system. It is also used for all the types of functional testing, such as subcontinuous testing. The base part of the testing that PyTest can do is the unit testing. So unit testing basically means a testing of very small lines of code. For example, just a function within the whole file. So the unit testing means that you want to test specifically a function within that file or a program. And actually in the next section we're going to do exactly that. We're going to create certain units that will run separately. So we'll write script consisting the units, and then we'll write in the command lines of PyTest that will test these units. And this is the first and the most basic part of testing with PyTest, and it's a very good way to start. Also, unit testing, of course, is performed in the technological companies if a system doesn't work, but you know specifically where the issue is. Next is the integration testing, and this is usually done when we're testing the communications between the different system components. Obviously here we're testing way larger amount of code, and we might test several classes or the whole subsystem. So in general we can say that the integration testing is way larger than the unit test, but smaller than the subsystem test. In some instances we would like to test the whole system, or this is called end-to-end testing. So this is when you have the whole system. For example, if you would like to test Android, you're not going to test each component of the Android system, but you're going to test the system as a whole. The idea here is to test the system as close to the user environment as possible. So we would like to pretend that you're the user that is using the system in the real world. Obviously, this is the most complex way of testing, and you have to learn some Python test functions and methods before jumping to this advanced topic. Then there is the functional testing, where we're testing a single bit of the functionality of our system. In this course we're going to do that, and we're going to add, delete and modify certain items in the projects that we are going to develop, so you will see how this is done as well. An important bit also of the testing is the subcontinuous testing, and here we're going just one layer under the user interface. So here we're testing under the API layer, but still this type of testing is called functional testing because it is directly related to the user experience from your product. So this is it, guys. These are all the types of testing I wanted to share with you. Now we are ready, and in the next videos we are going to start with the testing of the units, and I will show you how you can use PyTest in that case. This course is quite well organized, so you will see how progressively you will get from the unit testing until the system and functional testing, and how you can use PyTest in each and every of these cases. Before jumping to the next section and actually starting writing your Python test functions, I wanted first just to get and step back and show you each stage when we're testing code. So as you can see in front of you, here we're going to do a test. The test that you can see in front of you is quite simple, and this is a test that has been passed. So in the most base unit test case, you can see that you can simply create a test, okay, and this test is on the left where you see input function. So here you're writing a function in your Python file and you're testing some functionality. With the assert command you're usually testing if a statement is true or false. So if the statement holds, then the test is passed. If it doesn't hold, then the test is failed. And I know that for now this looks way too simple. Obviously in the real world we're not going to do these simple cases, but this is just done for the solely for the purpose of you to understand the whole idea of how we are testing our code. So as you can see, the input, what stays in the Python file, is the one on the left. Then once we move to the command line, we basically need to do two things, and this accounts for absolutely every PyTest that we are going to do in the future. So first of all, it is important to find the directory of the Py file you want to test, and then to run the test. Well, there are many ways to run your test because there are quite many functions attached to the PyTest, but for now we're just going to do the most simple one. So usually if you run the PyTest, you would write PyTest and then the name of the file you want to test. After this is done, PyTest starts searching for functions that start with test underscore. So since in our file we have the test underscore function that you can see on the left, this means that PyTest will activate and it will perform a test. And then in the output what you would receive is the number of tests that has been done, and this is only a single test since here we would have one function, and then you will get the result of the test. So when running the most basic command of the PyTest, we will not get too much information. So what we would get is the name of the file. As an output we will get test1.py. Actually here is 2.py, I just changed it. So we'll get the name of the file that we've just tested, and also we're going to get dot after the file if the test has been passed. And obviously you can write some options in order for you to see the result passed or failed with words, but in the most simple scenario, if you get dot after you complete your test, this means that the test is passed. But what happens if the test has been failed? So if the test is failed, and actually you can see here that a test is failed if, for example, the parameters of the left side of the equation are not equal to the parameters on the right side. So if you see the input function here we say 3, 4 and 5 to be absolutely the same as 5, 4, 3 and 3, which is obviously not the case. And in that case, after we run our file, we will get a failed test. And in the most simple scenario, as I said, without any additional options to the PyTest, when the test is failed, you are getting a capital F. And this indicates that your test has been failed, and you can see it in front of your screens. Obviously, if you are doing -v, which is the verbose method, you will see the word fail as a full word, and also you are going to see the function that has been failed. And the same accounts for the past. For example, here, if I write a function that is going to be passed, but I write -v for the verbose method, then you would see the name of the file, then the function that has been passed, and then the passed keyword because the function is already passed. And the same accounts for the failed method. So you will just see failed after the function, and some command lines are also going to display the color, obviously green for passed and red for failed. So this is what to expect, guys. Thanks for watching that video, and in the next one we're actually going to write our code and later test it with PyTest. Welcome to the IDE. First of all, I just want to state that I'm currently using the Eclipse IDE, for which I also showed installation in that video, but it really doesn't matter which type of IDE you're going to use. I was actually usually using the Xcode IDE, but since it is specifically used for Mac, for that reason I decided to use more unique and common IDE, which is Eclipse, but feel free to use any other IDE such as Visual Studio and so on. Wherever you like to use, it will work. Anyways, here I will show you how you can do this with the Eclipse, but as I said, in the most of the IDEs it is absolutely the same. So I will first create a project, which is going to be the project holding the files for our first section. So I'll create a new project, PyDev project, and I'll click next here, and then I'll write test2. Okay, so let's click finish here and we're ready. So this is the project where we're going to create our testing files, and you can see that there is nothing inside except the Python interpreter. So let's create some files. I will create a new file, and this will be PyModule. I will not create a package, but I will write the file name, and the first file will simply be called 1. Press OK here. And the second file, let's create one more file, so new PyDev module, and the second file will be called 2. Click OK here. That's it. So let's now add some information inside these files, and let's write some very simple tests. So in the file 1, let's write def test underscore passing. Actually, let's write passed, and then let's write assert, and then the numbers 3, 4, and 5. So we're going to compare that with the same. So write 3, 4, and 5. Let's save that by clicking Ctrl S, and let's go to the other file to write the failing test. So here I will write def test underscore failing test failed. Let's write the 2 brackets, double dot, and then assert. And here we need to write something that doesn't stand. So we would write items that are not equal to each other in order this test to be failing. So I write 3, 4, and 5, and this will be equal to 5, 4, 3. And since the numbers are not in the same order, this test should be failing. Also, the assert keyword is usually used to check if some rule has been followed or not. This is why we use it here, and we're actually going to use the assert keyword a lot of times, basically in almost every test, in order to compare some rules. So these are the 2 very simple tests, guys, and I will save both of them. So now the next thing you will need to do is to go to your terminal, and here's my terminal, and what you would need is to navigate to the folder that you have your files in. Okay, so since my files are in Eclipse Workplace Python, and I will show you where they are. So my files are in, let's say, the username and then the Python Workplace. Okay, so since my files are here, I know the exact folder where I need to be. And the first thing you need to do is to find the folder where your Python files are. So first do pwd, this is for Mac and I think Linux users as well, and you can see that I'm in users Martin Yanev. So I will do here cd Python workplace, okay, and when I click the tab button, it immediately recognizes which folder I mean, if it's the only folder that contains the first few letters that I wrote. So Python workplace, and then in the Python workplace I will search for PyTest 2. Okay, so when I click here, now I'm in the PyTest 2 folder, and actually if I open the folder from here, let's search where's the PyTest 2 folder, you can see that here we have nothing but the files that we just created. Okay, so since we're in that folder already, now we have access to both files. Okay, so I'll close this folder now, and let's run some tests. So here, if I write PyTest and then write 1.py and then run this command, what I will get is few things actually. So I will get that the test has been started, and then I will get 1.py dot. So the green dot here means that the test has been passed. Okay, and also under it you can see 1 passed in 00 seconds. Okay, next let's check now how about the other test, the test 2. So I write PyTest then 2.py, and here when I press enter you will see that we're getting a failure. So we're getting F, and not only this actually, you're also getting a description on the failure. So let's try to read that. First, here we're getting that on this line we've got the error. Then what we've got here is that at index 0 diff 3 not equal to 5. So this means since here 3 is not equal to 5, the test has been failed. And also we're getting a proposal to use the -v command in order to get the full definition. Okay, so let's listen to the program and let's use the -v. So here I will again run pytest2.py-v. Okay, and you can see that here when I wrote this command, the test obviously is again failed, but now we're getting a little more information. So here you can see that not only we've got error here that the 3 is different than 5, but also we've got these nice arrows that are showing exactly where the error is. And here we can see that 3 is different from 5, and also in the end 3 is different from 5 as well. And since the 4 is in the middle in both cases, as you can see also here from the background, we're not getting error here. So you can see already how useful is the PyTest for finding exactly where the error is. Not just stating that there is an error, but also finding where the error is. So I hope this helped you guys to a little bit warm up for the next sessions that we're going to conduct. Thank you very much for watching. This was actually the most easy unit test we can perform in Python, and in the next section we're going to get a little bit more advanced, but for that we'll speak later. You can actually see the same screen from the last video, and I purposely left it so you can be sure that this is our starting point. So today we're going to create 2 more files in which we will create 2 more tests that are a little bit more complex. So they're going to be related to tuples, which is something way more related to the real practice and how PyTest is used in the real world. So in that video I'm going to create the 2 files, and in the next one we're going to test them. So let's jump to the IDE and let me show you what I mean by this. So we're still going to work in the PyTest 2 project. So I will actually get closer here and I will go to the PyTest 2 project and then select PyDef module, because we're going to create the 3rd and the 4th test. So as you know, I would like to keep the things simple. So I will call this file 3, okay, and I will press finish here, press OK, and then I will create one more file which is going to be called 4, and this will be our test 4. Okay, so in the file 3, let's now write from collections import name tuple, as we are going to create tuple. And actually our tuple is going to be called dinner. So imagine the dinner has different features. So the dinner consists of food, the food is cooked by a cook, and the dinner whether can be ready or not, and also the dinner could have an ID, let's say the table number, right? So this is what we're going to create here in order to relate this example a little bit to the real world so you can grasp it way better. And for that reason, now just under this one, I will create dinner equals name tuple. Then let's write here dinner, comma, and then in the brackets we're gonna write the parameters that I just said. So food, then let's write clock, that's it, then comma, ready, okay, and finally I will write the ID or the identification number, for example, of the table. Okay, here there is a spelling mistake, I will remove one of the t's, so now both words match, and you can see how this error is removed. Now let's write just under it dinner dot new dot defaults, that's it. And here what we're simply doing is setting the defaults of the dinner components. So for that reason here I'll write in brackets firstly none, then none again, then false, so the food is not ready. And finally none. So initially the food is not ready, and the food, the clock, and the ID are unknown, or their value is equal to none. Then let's write a simple test. So write def test defaults, and here I will do t1 equals dinner, okay, and t1 is obviously a variable that is now equal to the dinner tuple that we just created. Then I will do t2 equals to dinner, and then in the brackets I write none, none, false, and then none, okay. And in the end I will simply check if t1 is equal to t2. So I write assert t1 equals t2, okay. So here we are checking if the t2, that is dinner with these parameters, is basically equal to t1, which is having the default values. As you can see, these values here are equal to the others, so this means that here our tests have to be passed. Now let's create another function, and it will be called def test num assess, and here I will write t equals dinner, and then let's use for the food for our dinner potatoes. So I write potatoes, and then the cook will be called Sam, okay. So here I assigned two values, and then I write assert t dot food equals potatoes, okay. So now I'm checking if the tuple t has food called potatoes, and also I will check if t dot cook equals to Sam. So I will check if the cook is actually called Sam. And finally let's check the rest of the values. So I write assert, then t dot ready, t dot id equals 2. So since we did not modify the ready and the id, this means that we would expect that they would have the default values. So we would like to check if their ready value is equal to false and the id value is equal to none, okay. So if everything works as expected, both tests here need to be passed, okay. So I will save that, and I will actually remove one of the equal signs here, because obviously here we're not checking any rule and it doesn't make sense that we use the two equal signs, and you can see that the warning from here is now removed. So this is our first two functions that are located in the test tree. So I will save that test, and I will move to test 4, where we're also going to create two tests related exactly to the same tuple. So let's again do the same initialization. From collections import named tuple, and then I will do dinner equals named tuple, okay. And here let's write the name of the named tuple, which is dinner, and then the parameters here will be a few. Again, food, cook, then I write done, so we'll check if the food is done, and then ID. Or actually let's do it ready, just to be the same as the last time. So I will do ready, that's it. And let's do the initialization. So dinner dot new dot defaults, and here the defaults again will be equal to none, none, false, and then none. That's it, guys. And let's create the other two tests. So the first test will be called test, actually def test as dict, and here's what we are going to do here. The first thing I will do is to create a new tuple. So I will do t dot dinner will be equal to dinner, and then I will assign different values to each of the parameters in that tuple. So I will do potatoes, then I will write comma, the cook I will call this time Peter, then the food is ready, so I will put true here, and I will do for table 34. Okay, now let's do another one. So t or t dict will be equal to t dinner dot underscore as dict. And as dict you can also refer to as dictated. So yes, this basically means that we're checking if the parameters of the t dinner are going to be as expected. So let's create the expected variable, so expected, and the expected obviously will be equal to the parameters that we just passed. So the expected will be food to be of a type potatoes, okay, then the cook, we would expect it to be called Peter, okay. After that, let's check if the food is ready, so ready, and we would expect the ready to be equal to true. And finally, the ID we would expect to be equal to 34, okay. So that's it. The expected variable is simply a dictionary, okay, and for that reason we're using this as dictated or as dictionary function in order to check if the parameters that are passed are the same as this dictionary that we are calling here, okay. So now since we have the dictionary and we also have the parameters that were passed to our dinner tuple, now we would like to compare them. And yes, you can use PyTest in order to compare even large data structures. So I will do assert and then t dict equals expected, okay. So now we're gonna check if the parameters passed to t dict, okay, you can see here the t dict are equal to the expected value of the dictionary, okay. And obviously here in the t dict we're simply passing the t dinner and we're taking the values in dictionary, and in the end we compare two dictionaries, so these two values here are of the same type. Now let's move on and I write def test replace, and here I will use the replace function and you will see how this is done. So first let's write t underscore before equals dinner, and let's pass new parameters to our dinner. So I'll first pass meat this time, then I will pass the cooker to be called Sam, then I will pass that the food is not ready, so false, okay. And these are the parameters that I passed first. Now if you would like to change these parameters, we can do t underscore after can be equal to t underscore before dot underscore replace. Let me actually get closer so you can see better. So in the replace function we can now change the variables that were passed to t after, to t before, sorry. So here I will do id equals 10 and ready equals true, okay. So imagine that you're working in a company and you simply want to change certain lines of the code, but obviously after that nothing guarantees that the variables were actually changed. Maybe you did some error. So for that reason you are going to use PyTest in the end in order to check if the changed variables are actually changed. So let's do the t underscore expected, and here you normally write what you expect from this function to give you. So I write dinner and then meat. I will expect the cooker now to be Sam. Then I would expect that the food is ready equal to true, and I would expect the ID number that changed to 10. Okay, so I would expect this, and I will try the values that I had before, okay, to be changed to the values that I will have next, okay. So we would expect that the t after to be equal to t expected. So I will do assert t after to be equal to t expected. Okay, and if this is the case, then the test will be passed. So these were the two files, guys, that I wanted you to create. I hope you successfully created them. In any case, if you see any errors, obviously I will provide you these files in the code attached to this section, so don't you worry. Thank you very much for creating them, and in the next section we're going to check if I did any errors inside them. There is always a possibility that I did errors in the code, but since we're doing PyTest course, you will see in the next section that even if we have errors, we will detect them very easily and we will fix them. Okay, now you're ready with all the files from our folder, guys, and now let's go to the terminal and let's try to run these files. Now I want you to notice something. If you went out of your terminal, please go back to the folder that consists of your files, like I showed you in the previous video. So since I'm already in the PyTest 2 folder, now when I simply write PyTest, I can run all the files in there. So let's first write PyTest and press enter here. So now let's run the test 3 and let's see if everything works fine. So I write PyTest and then I'll write 3 and then hit enter here. And okay, you can see now that we have one mistake here in this line of code, and maybe I did an error. Okay, so as you can see, we're having an error in function 2 because we're getting first the dot and then we're getting function 2. So let me have a look in the second function here. So as you can see here, it is saying that I don't have the cook variable inside the dinner, and this is true actually, because instead of cook here I wrote clock. So I remove the L and now I know that there is an error in this function. So let's run the code once again. Actually, let's save it first and let's run it once again and see. So here I still get an error. Let's run the verbose method and see how to fix it. So I will do 3.py minus v, and we can see that the second function test underscore numassess has failed, and here obviously I missed the second O. So now since here I have cook and then in the function I have cook as well, let's see if this can be fixed now. So I will press here again. Okay, sorry, I need to save it first. Then let's run the function once again. So PyTest 3.py minus v. And now you can see that both of the functions are fine, because now I fixed the error that I found out with PyTest. So let's run the second function now and see if everything is going to run fine. So I will write PyTest 4.py, and as you can see here, luckily I've got both of the functions right. Let's run the file 4. So I've got both of the functions right and the test has been passed, so both of the functions returned true variables from the assert function. You can also see that in both tests the time that was taken was 0.01 seconds. You can see that here, and this basically gives us all the information needed for us to know when we run the test what has been passed and so on. Now the next thing I want to show you is that you can also run custom multiple files with PyTest. And how this is done: you can write PyTest 3.py, let's say 2.py and 4.py. So let's run that, and you can see that we now run all of our functions, and you can see that all the files here I run one after another. So first we run the 3.py, and 2 dots means that there were two functions which were passed. Then in the file 2 we've got one function that failed, and in the fourth file we've got two functions that failed. And also, as the last time, you can see where the error is in that function, and also in the end you can see that there is one failed and 4 passed tests. So for example, if now I run also the -v for the verbose method, you can see that you're getting absolutely every function here with the keyword passed, and also you're getting the failed function. Actually, these additional options can be expanded further than simply writing the verbose method in terms of -v, and I will show you this not in the next but in the video after, and we're really going to expand and see the different options that you can include in the PyTest before going to the more advanced tests. So guys, that was everything for today. I hope it was useful to see multiple files that can be run and how to find and actually fix an error using PyTest. In this video, I wanted just to step back a little bit and talk about the different things displayed on the output once you're running a PyTest code. This might help you in the future to understand better what the output of every of our commands looks like. So to do this, first I will actually run some tests that we already run in the previous videos, and then we will describe the output. So you can see here in the terminal, I will go back to the folder that we saved all of our tests, and I will actually run 3 of them, test 2, 3 and 4. So let's run them, and here's your output. Actually, let me make this window bigger and I will run the tests again so you can see them better. So now, since we run the test, let's talk about each component that has been displayed in front of us in that test. So here is our line that we run, and the code after this is called the output. So the first thing you can see is the test analysis starts, and this line here with a nice delimiter is generated once you run your code. So this is basically the starting of your output. Now the next thing you can see is the platform drone, and then you see some versions of Python and also some other packages, as well as the Python key folder. I think this display is local for the Mac users, and this is the way that your computer is saying what version of Python is used for the test, and also what packages are used as well in the test. And in the end, you can see the folder where your Python module that runs the whole code is located. So if you want to use it for reference, you can find it here, and also if you get any unexpected results, you can also check which versions you use and maybe you would like to update them or go to a previous ones. Then you are getting the cache directory, and obviously this directory is basically created automatically once you run the test. And if I actually now go to the folders, so I'll go to Python workplace and I will go to PyTest 2, you can see that a new folder is created and it's called PyCache, where you have the cache of all the tests that you have done. So this is basically the folder that is referred here. So the thing that you can see next, obviously it should be clear for you, this is the directory where your tests are. So since our folder is user, my name Martin Yanev, Python workplace, PyTest 2, this means you will see this directory again for reference, so you know where you're actually running your tests, which is quite useful. Maybe now it's not important, but believe me, if you are doing a very big projects on PyTest, you definitely want to pay attention on the folders that you are using. The next line shows the number of tests that have been run. So even though we run 2 files, you remember in one of them we have only a single test, and in the other 2 we have 2 tests, and for that reason we're getting back that our total tests that have been performed were 5. And again, this is quite important when you are testing big amount of files. So if you see a big difference in the number of tests, then you know that something is wrong and you definitely would like to check your files or your results. After that, you are getting each test by first stating the file that contains the test and then the name of the test function. So after that, you are getting either passed if the test has been successfully completed, failed if the test has failed or the rule that you stated there is not met, but also there are some other options that we are actually going to cover in the next sections. One of the options is called skipped, which means that you tell to the compiler that you want to skip that test. Later on I will show you how this is done. Also, you can have the xfail and the xpass. This is the case where you're creating a test and you state that it is correct if the test has failed. So if you create a test that's supposed to fail, you're going to get a result xfail if this is completed. And finally, the final thing you can get here as a result is the error, and this is usually if you have a certain error inside your code but outside this function. So let's say you're writing a few tests, but also outside these tests you have some other lines of code which fail to execute, then you would get a result of an error. So this was everything I want to share, guys, with you. I hope now the output of the PyTest is quite clear for you. Thanks for watching, and in the next lecture I will show you some additional options that you can use in your PyTest in order to make better visual results to yourself and to your colleagues. I decided to start this video with this weirdly looking slide, but don't you worry, I will explain you everything inside it. So what you can see in front of you are all the options that you can use with the PyTest, and in this video and maybe in the next one as well, we're going to talk about each and every option so you can learn them before starting with the more complex projects. So as you can see, there are quite a few of them, and I'm not sure, even actually I'm sure that we will not be able to cover them in a single video, but in that case I will create part 2 of that video so we can cover absolutely everything and you can really understand it. So let's head on to our terminal and start running the tests with these options, and let me explain you each and every of them. So as I said, these options are quite important because by knowing them you can basically control the output that is shown to you once you're running your tests. And the first option that I'd like to show you is the help option, which basically shows you the rest of the options with a little description. So if I do PyTest and then I write --help, you're getting quite a lot of information, and let me actually make the screen a little bit bigger so you can see better. So as you can see here, you are getting every option. So see here you will get the general option, and for example we get -k is expression, and here you are getting the description of what -k does. Then you will get -m and so on. You have so many options, but in this video we're going to cover obviously the most important of them that you can practically use. So I'm not going to go over every option of the help, but I will actually show you how the most important options work right now. So the first command that I actually want to show you is the collect only command, and this command will show you which tests will run at given options and the configuration. So let me show you how this is done. If I write PyTest, we're actually getting 0 items. And this is because our projects are located in a space different from the space that the PyTest has been installed. So let me fix that and let me show you, if you get the same problem, how you can fix it. Now I will go to the folder where my project is located, the PyTest 2, and I will actually copy it, and I will create a folder in my documents folder. Okay, so I'll create here a new folder, and this will be called PyTest directory, and actually I will make the rest of our tests exactly in this directory. So let me paste our project here, and you can see that now in my documents folder I have the PyTest directory where I will start storing my files. So let me actually exit Eclipse, and once you open it again I want you to select the folder that you just created here. So for the workplace I will select browse, and I will navigate to the folder that I just created. So it's gonna be PyTest directory. That's it. And press launch, just so you also set your Eclipse for this code. So you can see that this is not running and it cannot find any tests, and there is a reason for that. Do you remember that in the beginning I told you that PyTest is usually looking for files that start with test? Well, the same is if you run the PyTest, it looks for files that start with test. And for that reason, you need to go to PyTest 2, and you see how we named our tests 1, 2, 3, and 4. So in order for PyTest to find them, we need to rename them, and you can do this by selecting the F2 button, and instead of 4 I will do test underscore 4, and I will select OK. So now here we have one test. Let's run again PyTest collect only, and let's see what will happen. So now, as you can see, the test 4 is running because the file now starts with test. Let's do the same for the rest of our files. I will go to the ID and I will simply rename them to test underscore 1. Then I will do test underscore 2, and finally test underscore 3. And this is the way that Python can find the files. So I will actually show you something very cool, that since our files all start with test, you can simply run PyTest and it will run each and every file in that folder that starts with test. So if I simply run PyTest, you will see that every test runs as expected and will run 6 items, which are the total number of functions located in our 4 files. Now, since we already know how to run everything in our folder, let's go back to collect only method. So you can do PyTest, then double dash and collect only. Okay, I think I missed the other dash last time. So let's run it and let's see what happens. Now, once you run this function, you see that there are no results, but we're getting actually quite an important information. So when you select collect only, you're getting a list with the name of the file and the functions inside this file. And since we have 4 files, now we can see each and every function, the name of each and every function inside this file, and you can see that the functions are a little bit in comparing to the position of the file. So you have a very nice graphical interface on how these functions are located, and you can use them in your favor. Now, sometimes you will face a problem, especially if you have a very large files with a lot of functions that you'd like to run a specific function. And sometimes you would require a shortcut in order to run that function, especially if its name is unique or running set of functions with the same prefix. So as you remember, in some of our files we have obviously different function names, and maybe we would like, let's say, to run the function that is called test defaults in all of our files, let's say, or the test asdict. Okay, so we want to tell to the compiler that we want to run specifically function with this name in every file, and here is how you can do it with the -k. So there is an option called -k, which you can do like PyTest -k, and then in the brackets or in a quotes actually, I will write asdict or defaults. Okay, and the first thing I would like to do is actually to check if there are any functions with that description. So I'll write also collect only, and let's see if there are any functions with that description. So here, when I run the -k and the collect only, we can see that there are actually 2 functions in our test file 4 and test file 3 that match the description. Okay, so since we have function that has asdict and defaults, this means when we run the line without the collect only function, we will actually execute only these 2 functions. So let's write PyTest -k and then asdict or defaults. Okay, so once we run this, you can see that now we run the 2 functions and we passed or we deselected 4 functions that don't match this rule. And this is a very powerful command if you want to run only functions with the same prefix or keyword inside them. The next function is called marker, and we usually use it when we add -m, and this allows you to run specific functions that you previously marked in your code. So what you are doing, you are simply adding a marker before the functions that you like to be associated with this marker, and then you can assess the marker with the -m function. So let me show you how this is done. Let's first go to Eclipse and modify our code a bit. So let's go to our test replace function and let's add a marker there, and usually do it with the @ symbol. So I will do PyTest dot mark dot run first. Okay, and this is our marker inside this function. Now you can see that there is an error here, and this is because we will need to import. Actually, I've imported here, so we'll import the PyTest. Okay, as you can see, for now we didn't import the PyTest, but now since we imported, you can see that this error here is removed because we can use this specific package, which is quite cool. Now let's also add this prefix to some other function in other file, and let's add it to test number assess. So I will go here, add absolutely the same marker, and I will also import the PyTest. So import PyTest. Okay, so now you see that the error here will be removed. And after that, let's go here and write the following lines of code. So I write PyTest, okay, then I will add -v for the verbose method so we can see more information. Then I will write -m to look for marker. So now we're looking for the name of the marker, which was called, let me actually have a look, run first. So I write run first. So we've actually got an error, and this was because I didn't save the test for functions when I added the PyTest. But now since I added it, let's run everything again. So PyTest -v -m run first, and when I run this, you can see that only two functions run, the test replace and the test num assess, which are exactly the functions that we actually marked with our marker. And again, this is quite useful if you know that in the future you would like to run functions, actually a specific set of functions with particular lines of code. So you can add different markers, and with the -m function you can always run them. We're obviously getting a warning here because we used a custom marker that we designed by ourselves, but that's fine since the compiler found both tests and run them successfully. Now the next function is called exit first, and we implemented by the -x command. And this is because imagine that you're debugging a code. The normal behavior of PyTest is to run absolutely every test regardless if something failed or not. And sometimes you want your program simply to stop on the test that failed first. And this is what the -x command is doing. The PyTest execution will stop exactly on the function that failed first. And let me show you how this is done. So let me first just write PyTest. So we run all the functions, and you can see that we have one function that is failed. Well, this is sadly the last function here. So for that reason, let me actually introduce an error in the test tree as well, so our code can stop on the previous test. So let's go here to the test num assess, and here instead of false I write true. And this should potentially introduce an error. So let's save this file, and I will again run the PyTest, and you can see that now here we have another failed function. So let's run the -x command and see where our execution will stop. We would execute the last function, which also have a fail, or it will stop on the test tree. So I will do PyTest -x, and as you can see, once we run this, so here is where I run the command, and you can see that here now we stopped at the test tree on the second function that is failed, and we didn't execute the tests after that. And this is a way that you imagine that you have 1000 tests. So if the second test is failing, obviously you would like to stop there, fix it, and then re-execute everything until you find the next failure and then fix it. And you really need to remember that function because it's quite useful in the real life and it can definitely improve your testing experience. So guys, the time is going actually quite fast today, so that will be everything for this video, but in the next one we will continue with the rest of the additional functions to the PyTest. This is the next video from the sequence where we're actually executing the PyTest options, and I'm showing you each and every one of them. As you can see in green, now I marked the options that we executed last time, and today we're going to continue with the rest. So let's not lose any more time and first start with the maxFail function. Obviously, as the name says, the maxFail function allows you to determine how many functions can be allowed until the program stops. I will actually first remove these tags here so we don't get these warnings anymore. I will remove it from the PyTest 3 and from the PyTest 1. Sorry, from the PyTest 4 as well. So let's actually run first simply PyTest so we can see that everything is fine. Okay, we're getting 2 errors, which is normal because we had made 2 errors purposely in the past. So now let's talk about the maxFail function. Obviously, the maxFail function allows you to say how many errors you can have until your function or your execution stops. And for that reason, let us go now to the test 4. So let's go to the test 4 and introduce an error there. So I will here, instead of sum, I will write mic. Okay, and since there is an error, so the elements doesn't match, we should get additional error here. And as you can see on the first function, we're also getting an error. Now, let's say we get 3 errors now in all of our functions, but this is too much for us. We want our code to stop executing on the second error. And if we use the -x, we are allowed to have only 1 error. So in that case, you can do PyTest, then maxFail, and the maxFail will be equal to 2. So let's run this and see what happens. And as you can see here, since we allowed only 2 errors, we're getting the first error, we're getting the second, and we stop there. So we do not continue after the second error. And now we can fix these 2 errors and then continue with the rest of the code. This is very good. So since we are ready with this one, let's talk about the capture method. This option is actually something that is not widely used. It is usually used in order to change your standard output of what you see on your screen once you run the code, but since it is not that often used, I'm not going to show it right now. Maybe you will see it in our next projects. So let's move on. The next function I actually want to show you, and I will show you how it works, is called the last failed function. You know, sometimes you don't actually care about the functions that have been passed, because since they were passed, you don't have to do any work on them. For that reason, you might find it quite useful to show to the user only the tests that have been failed. And I will show you how this is done. This is by the last failed function, or LF. So if I write PyTest dash LF, actually is double dash, that's why we get this error. So PyTest double dash LF, what you are getting here is no past tests. You are getting only the tests that have been failed, which are 3, and we can see in which files were these tests. So since from 6 tests, 3 are failing at the moment, we're getting only the results for them, which some people might find it quite useful, especially if you run thousands of tests and you want to see the few that were failing. So after you run this, you can also see here the summary info of all the failing tests and the specific functions that were failing. A quite similar function to this one is the failed first. And what this function does is it is structuring your tests by showing first the failed tests and then the passed ones. So if I do PyTest and then I write FF for failed first, then what you would see is again 3 failed and 3 passed tests. So you're displaying the passed tests, but if you check here, you're getting first the 3 failed tests and the files in which they are located, and after that you're getting the passed ones. Again, if you have multiple files, obviously it's quite helpful to display the tests that failed first on the top. And even if you use this one with the -v command for the verbose method, you can also see the full information about the specific tests that have failed and the keyword failed here. So this is quite useful, and actually I always use these two keywords in combination in order to display the failed tests first and to get the right descriptions for the tests that I like. Now, if the verbose option is showing you too much information, and even if the standard display by simply writing the PyTest is showing you too much information that you don't actually want to see, you can actually try to make this way shorter by the quiet option. So if I write PyTest -q, then you're entering the quiet mode, and you can see that here even you don't see the functions that have been failed, but you are simply getting one after another every symbol of the failed and the passed tests, which is way shorter. So this is used usually if you would like just to very fast and in a small amount of space to have a good look of what your current situations about the past and the failed tests are, and you want to read it very fast. The next option that I will show you is called show locals, and this is showing actually the local variables of the failing tests. And obviously the best way to show you this is by practice. So I write PyTest and then I write -l for locals, and let's see how will this work. So you can see that the difference here is now the local variables, the t after, t before, and t expected, for example, for this first test replace function, are shown here. And these are the local variables that are defined in the function. So if I go to the test replace function now, you can see the test replace. These are the local variables, t before, t after, and t expected. So the idea here is for our program to show us exactly all the local variables so we can see them and use them. For example, here I can see that the local variables t expected has a different name of the cook, which is called Mike, and I can use that just to gain some information and see what the error actually is. Obviously, if the expected result is different than the rest of the variables, then I might consider that this here is the wrong word, which is actually the current case. Also for the other functions, you can see that here t is the single local variable and so on. Now, you know, sometimes when you run your tests, you're actually always see the help that the PyTest is giving you inside the function. So you're seeing this multiple lines of code with the potential error and you know where the error is. Sometimes maybe you wouldn't want to see this information. Maybe sometimes you just want to check your tests and just see who is passed and what is passed and what is failed, but without the additional information provided from the PyTest. So you can fix this quite easily, and this is with the style option. So the style option is very simple to implement. You simply write PyTest and then write $TB, which means that you want to assess the style mode, and write no. Okay, so this means that you are not going to see the tracebacks. These boxes here, they are called tracebacks. So if you don't want to see them, you can say tracebacks no. So if I run this, now again you are getting 3 failures, but you are not seeing the tracebacks, and you are getting this compact look of your code, which is quite useful for me, and I hope it will be useful for you once we run our advanced projects in PyTest. The next thing I will show you is something that is checking the duration or the time for execution of your tests, and it shows you which are the slowest tests that have been run by your command. For example, if I write PyTest, okay, and then double dash durations equals to 2, then the system will show me the 2 tasks that were executed the slowest. So once I run this, you can see that here in the durations tab, it doesn't actually display the functions that were the slowest, because all the functions run quite fast in less than 0.05 seconds. But if I write minus W after that, it will actually show them, even though all the functions were quite fast. So I write dash W, let's run it again, and you can see here that the slowest 2 functions was a test replace and the test failed. Now, if you want to see some more significant numbers here in the tests, let's add actually time sleep into our functions. So in one of the functions here, I'll add time dot sleep, and here I will add a sleeping of 0.1 second. You also need to import the package time in order for this to run. So I imported here time, and then I can write time.sleep and 0.1 second. So let me save that, and let's run the command once again. So you can see that now we've got one test that runs for 0.11 seconds, which is a test replace, and this is because we added this time sleep function here. So you can see that this command quite easily can actually find the tests that run the slowest and that could introduce potential performance issues for you. So you can definitely use it while you're running your tests, especially if you care about the durations of your tests. So that was actually everything for today, guys. I will just finish by showing you how you can check the version of your PyTest. Sometimes you might find it quite useful, especially if you use it for a long time and you want to see if your version is outdated. So you can simply do it by PyTest double dash version, and then you will get the version of your PyTest, and my current version is 6.2.2. So I think that was everything for today, and we covered quite a lot of methods. Believe me, these are the best methods and the most commonly used ones while running PyTests. So pretty much you gain all the knowledge you need to continue with the more advanced projects. But that was everything for today. Thanks for watching, and if you want to check out the rest of my completely free programming courses, you can definitely subscribe my channel. I am uploading courses weekly, so there are plenty of new free skills that you can learn.